Hi there, welcome to Twisted Features. I'm your host, Merchant. Today we're going to be watching Making Nylon with NileRed, one of my favorite YouTubers. He does all these crazy science experiments, explains how it's done. Check out his channel on NileRed. Check out his alternative channel, Nile Blue, where he shows you what he does with all the extra stuff that he ends up discarding during his channels, all the in-between cutscenes. Anyways, let's get to seeing how nylon is made. I'm actually looking really forward to this because I've been curious about this.
This video is sponsored by Audible. Nylon is an extremely important family of polymers that can be used to make a huge range of different products. It can be strung into fibers to make things like clothing and textiles, or molded into plastic parts and tools. Nylon was first used to make the bristles for toothbrushes, and it's still being used today. It's also used to make women's stockings, which have become known as just nylons. There are many forms of nylon, but the most common ones are nylon 6 and nylon 6/6. Each type of nylon gets its name from the length of its building blocks. For example, nylon 6/6 is made from two ingredients where each one has 6.
For those of you that understand this, this is gibberish to me. This just looks like a bunch of drawings to me. I know these are like formulas and stuff of how, I guess, how the bonds of the different parts of substance there is here, but I'm not entirely sure what exactly. Don't take my quote on that.
Carbons. Nylon 6, on the other hand, is made from just one 6-carbon chemical. There are other forms of nylon, like nylon 4/6 or nylon 6/10, but they're not as common. The different lengths of the building blocks gives the final polymer different properties, which makes them useful for different things. For example, nylon 6/10 is better at retaining its properties when wet, so it's the nylon of choice to make things like toothbrushes.
I'm gonna be honest with you guys. I'm gonna fast forward it a little bit here. Um, you guys can watch the full video when you get there. Let's get to the interesting stuff. You guys can learn something on his channel. I want to see how nylon is made, and I'm sure you guys do too. But those who don't understand chemistry probably will not understand this. So let's do this.
Chloride, and to do this, I'll be using four main chemicals: DCM, DMF, adipic acid, and oxalyl chloride. The adipic acid was made in a previous video,
Oxal.
and I'll have a link in the description if you want to check
That's
it
a
out.
weird word.
Instead of oxalyl chloride, it's possible to use other chlorinating agents like thionyl chloride, but they're a lot harder to get. A lot of them are listed as precursors under the Chemical Weapons Act, so they're not exactly the best thing to own. The adipic acid isn't super pure, so before getting started, I decided to clean it up a little. I dumped it all into a beaker, and then I added a whole bunch of distilled water. Although adipic acid isn't very soluble in water, we still don't want to add too much here. Before continuing, I quickly checked the pH, which came out to be around 3, which is expected for adipic acid. I made a solution of about 6 molar sodium hydroxide, and I started to add it slowly.
See that stuff
The sodium
bubbling on
hydroxide is
its
a
own?
strong base,
Like
and it will
it's
quickly react
there's
with
a
the adipic
chemical
acid
reaction
to form
happening
sodium
there.
adipate
We're
and
watching
water.
it as it happens.
Unlike adipic acid, sodium adipate is very soluble in water, so as we continue to add the sodium hydroxide, the solution should clear up. I know I'm done adding sodium hydroxide when I get a pH of around 7. All of the adipic acid should be in the form of sodium adipate, and the cloudiness here is due to impurities. The impurities that are present seem to be very small particles, which tend to easily pass through filter paper. So to get rid of them, I have to instead filter it through something called sea light, which is very similar to extremely fine sand.
Oh, that's cool.
The solution passes through relatively slowly, but the stuff that I collect is crystal clear.
So instead of using
Once
a
everything has
sifting
been filtered,
base, he's
I
using
wash the beaker
like
and the
something
funnel
like
with a
an
little bit of
excessive
distilled
amount
water.
of sand particles on top,
I
just so
again
that way,
wait for
like,
all of this to pass through,
it
then I take
passes
away the
down
funnel
super
and I
slow
drop in a
compared to
stir
the
bar.
ladder.
So now
The
that I've
hell?
cleaned things up a little bit, it's time to regenerate the adipic acid.
Did he spin
To do
that, or is
this,
that
I
spinning on
add
its
6
own?
molar hydrochloric acid until I get to a pH of around 1. The hydrochloric acid reacts with sodium adipate to make adipic
If you
acid
guys look
and
closely
sodium
right here at the
chloride.
bottom, you can
The
actually
sodium
see,
chloride
if
is
you look
very
at the bottom
soluble
of
in
the
water,
glass, you can
but the
actually
adipic
see that
acid
it's
isn't, so it precipitates out.
spinning still.
I continue adding the hydrochloric acid until I get to a pH of about 1. The beaker is placed in a freezer and cooled to around 5°C, and then the adipic acid is filtered off. The beaker is washed a few times with a small amount of distilled water. Once everything was pulled through, I turned off the vacuum and did one final and thorough washing. I turned the vacuum back on and I left it running for about 20 minutes to try to dry it up as much as possible.
So all that stuff left
Welcome
is
to Raid
acetic
Shadow
acid,
Legends.
I'm guessing.
If you're wondering
So,
just what you're
that's
getting
weird.
into, Raid Shadow.
I scraped the adipic acid out of the filter and I let it dry for 2 days. When I came back, it was a relatively dry powder and I transferred it back to the original container.
That's a lot less than it was before.
Okay, so now we're ready to do the actual reaction, and I start by dropping in a magnetic stir bar. I then add
It's a
5 grams of
magnetic
adipic
stir
acid,
bar.
followed by 70 milliliters of
Okay.
dichloromethane.
I'm not entirely sure how
And the
whole
last
thing works
ingredient is
completely,
a
but I
small amount
do
of
know that I
dimethylformamide, which
believe
will be
one side's
acting as a
magnet, one side
catalyst.
is a loose piece inside
I
the
took away the
container that
funnel
allows it
and
to
I
spin
replaced it with a
continuously
vacuum adapter.
after giving a little momentum.
Above the adapter, I attached a small addition funnel and I added
Again, don't take my word
11.6
for it.
milliliters
I may be
of
completely clueless about it.
oxalochloride. Oxalochloride is a very dangerous and corrosive liquid, and you can see it fuming. It's a very strong chlorinating agent, and I do my best to avoid working with it. To the vacuum adapter, I attach some tubing which leads outside. This reaction produces a lot of hydrochloric acid gas as well as carbon monoxide, so this definitely cannot be done in a closed space.
Also, I hate
My
to just strip
workspace is
everything
extremely
off all
well
your
ventilated,
workstations.
and I just added this tubing as an extra precaution. When I was ready to get things started, I turned on the magnetic stirring. Most of the adipic acid is not going to
that's
dissolve,
cool.
and this is perfectly fine. I open the
You say you
addition
turn it
funnel,
on the
and the
magnetic stirring, so
oxalochloride
maybe
is
my
added
idea
over the
is
course of
completely
about
wrong.
5 minutes. My dichloromethane and adipic acid aren't perfectly dry, so there's a little bit of water present. The first little bit of oxalochloride that's added is going to react with the water, and it can sometimes be pretty vigorous. It's highly unlikely that it would ever cause it to bubble out of the flask, but it's
it's
just a good
bubbling.
precaution to take.
Cool.
Anyway, so as I said, the initial reaction is just with water, which produces hydrochloric acid gas, carbon monoxide, and carbon dioxide. Once it reacts with most of the water and gets rid of it, it will start to do what we actually want it to do, which is react with the adipic acid. When it does, it will convert carboxylic acid groups to acyl chlorides and lead to the formation of adipoyl chloride. It will also produce carbon dioxide, carbon monoxide, and hydrochloric acid gas as side products. This is why it's really important to have good ventilation, because you really don't want to be breathing in hydrochloric acid or carbon monoxide. Because oxalochloride reacts with water, and I want to make sure that all of the adipic acid is consumed, I need to use an excess of it. I used about twice the amount that was required, which assures that the reaction will go to completion, but it also means that oxalochloride will be left over at the end. I'm now just going to quickly go over the mechanism. In the first step, the electrons on the nitrogen of DMF move to form a double bond. The other double bond opens up, and the electrons go to the oxygen. The free electrons of the oxygen then attack the carbonyl of oxalochloride and open up the double bond. The electron off. The fills another off and a kickoff did lastly disappear. During this period, the bubbling slowed down a lot, and the solution slowly became more and more yellow. Adipoyl chloride is slightly yellow, so this color change is a good sign. Eventually, all of the adipic acid was consumed, and there was no visible bubbling. From this point, the solution was stirred for another 24 hours. 24 hours later, the solution is significantly more yellow. It's also opaque due to impurities, which will need to be filtered off. To do this, I filter it through some sea light and glass wool. Before filtering through the actual solution, I wet the sea light and the glass wool with a little bit of DCM. It's important to use glass wool and not just regular cotton, because the oxalo chloride and the adipoyl chloride would probably destroy it. I tossed away the solvent that passed through, and then I started filtering the real thing. One thing to be aware of is that adipoyl chloride is sensitive to water, so it will react with moisture in the air. In theory, it's best to do this in a water-free environment, but I don't have one, so I tried to just filter it as fast as I could. One thing that's helpful is that we have excess oxalo chloride left over. Oxalo chloride is much more reactive, so in theory, it should be able to pick up the water and protect the adipoyl chloride. Once everything had passed through, a small amount of dichloromethane was used to wash the round bottom, as well as the funnel. When this was done, I took away the funnel and I dropped in a stir bar. Okay, now I need to get rid of all of the dichloromethane, as well as any unreacted oxalo chloride. And to do this, I set up a simple vacuum distillation. I set up a hot water bath, and with strong stirring, I slowly turn on the vacuum. It's really important to engage the vacuum slowly, otherwise it could bubble out of control. I continue with the distillation, and unfortunately, at some point it becomes opaque again. This isn't a huge deal, but it does mean that I have to do another filtration. Anyway, I keep going until it completely stops bubbling, and I'm left with this dark orange residue. In a previous run that I did, it didn't turn orange, and I just had a yellow liquid. I'm not exactly sure why there was such a difference here. In either case, though, I had a mixture of adipoyl chloride and a bunch of solid impurity. Unfortunately, most of the impurity comes from the dirty adipic acid that I started with. If I started with very pure adipic acid, I probably would have had relatively clean adipoyl chloride at this point. Anyway, it is what it is, and I now need to separate my adipoyl chloride from the other solid junk. To do this, I start by adding 50 grams of dry cyclohexane. The cyclohexane will dissolve the adipoyl chloride, but it won't dissolve the other stuff. After it's added, I put the stopper back in and I stir it for about 10 minutes. To filter it off, I do the exact same thing as before, where I pass it through sea light and glass wool. Before I pour it in, I wet things with about 2 grams of cyclohexane. Anyway, the cyclohexane solution is added to the funnel, and it slowly starts to filter through. At this point, we can see that the solution itself is yellow, and the orange color is coming from the solid stuff. I added as much as I could without including the solids to try to get it to filter through as fast as possible. Once almost everything had filtered through, I poured in the last bit that remained. The flask in the funnel was then washed twice, first with 10 grams of cyclohexane, and then with 16 grams. In total, I used 78 grams of cyclohexane, which is almost exactly 100 milliliters. I wait for everything to pass through, and when it stops dripping, I take away the funnels and I cap the bottle. What I have now is roughly a 0.2 molar adipoyl chloride solution, which will be used directly to make the nylon. The solution is a little bit opaque because some of the adipoyl chloride reacted with water in the air and precipitated adipic acid.
This game, you're not ready for.
To make the nylon, I need to make a solution of hexamethylene diamine. When I open the bottle and take a look inside, it's completely solidified and it has formed some very nice crystals.
So does he have to chip it out or something?
With a lot of difficulty, I scraped out 4.4 grams and added it to a beaker. Hexamethylene diamine is quite corrosive, so it's important to wear gloves and be careful when handling it. I added 50 milliliters of distilled water and I stirred it until everything dissolved.
Oh, that's cool looking.
Some of the flakes floated to the top. I stirred it until everything dissolved.
Look at that. That's gorgeous.
Some of the flakes floated to
It's
the
like
top and started to zoom
little
around, which
see-through
I thought was
fish
pretty
floating
interesting.
in there.
Anyway, once almost everything had dissolved, I topped it off to about 100 milliliters. With the hexamethylene solution prepared, I'm ready to make the nylon. The adipoyl chloride seems to have gotten a little bit cloudier, but that's not really an issue. To make the nylon, it's pretty simple. I first add a little bit of hexamethylene diamine solution, and on top of this, I carefully add an equal amount of adipoyl chloride. The adipoyl chloride is dissolved in cyclohexanol, which doesn't mix with water, and it's less dense, so it floats on top. Because they're not mixed, the only place that polymerization can take place is at the interface between the two solvents.
Oh, that's
Using
cool.
a pair of tweezers, I can pinch the nylon and pull it out of the beaker. The gooey string is wrapped around a glass stir rod, which I can then turn to pull out more nylon.
That's even cooler.
What's interesting here is that pulling out is not actually a string, it's more like a tube. The tube isn't hollow though, and it's often filled with hexamethylene diamine solution, so it's important to be careful when handling it. So now to talk a little bit about what's going on here. When the adipoyl chloride comes in contact with the hexamethylene diamine, it reacts to form an amide bond. However, on one end of this newly formed molecule, we have an acyl chloride, and on the other, we still have a free amine.
Look at where it's being pulled
So now the
from.
reaction can repeat itself, and it keeps doing this over and over to form a very large molecule known as a polymer.
Oh, that's cool.
It looks like there's a whole bunch of nylon here, but it's a little bit deceiving because it's being puffed up a lot by the water that's being pulled up with it.
I bet. It's probably like a fourth of its size.
It eventually runs out of either the hexamethylene diamine or the adipoyl chloride. When I squish it with my fingers, you can see that there's a lot of liquid with the nylon. To try to clean it, I dump it all into a water bath.
That's cool.
Without destroying the nylon, I manually pull it apart to try to give it a better washing. After about 30 seconds, I just leave it there to soak, and I move on to making more nylon. I tried it again using the same amount of each ingredient, but this time in a much larger beaker. It ended up being pretty much the same thing, and the only difference was that it was a little bit faster. There's a larger surface area between the two layers, so we pull more nylon with each turn. It was a little bit tedious doing all this turning, so I tried to make things a little bit more automated. A glass stir rod was taped to an electric drill, so this time I just need to click a button to pull out the nylon. For this run, I decided to see what would happen if I just mixed the two layers together instead of pulling the nylon out. As I continue to stir, it slowly forms the nylon and turns into a somewhat disgusting mess. After about a minute of stirring, I'm left with an alien-like blob stuck to the end. When we take a closer look, we can see a whole bunch of air as well as liquid trapped inside.
That is really cool looking. I like that.
I then attempted to get creative by adding some fluorescein to the hexamethylene diamine. Fluorescein is a highly fluorescent molecule, especially under UV light.
That's cool.
I actually made it in a previous video, and if you're interested in checking that out, there's a link in the description. I turn off the lights and I turn on my UV light, and then I carefully add the adipoyl chloride.
Okay. Well, let's see what happens.
Just like before, I use the tweezers to pull out some nylon.
That is cool looking. Oh my, it's like this guy's like
What's kind of
spinning
cool
alien
is that we can
spider
tell
webs.
how much water we're pulling up with the nylon
Look at that.
based on how bright it fluoresces. At some point, I accidentally got the nylon stuck to the side of the beaker. At first it was a mistake, but it ended up being pretty interesting. In hindsight, I wish I put down the glass rod, and using my fingers, I probably could have pulled off a super thin sheet of nylon. In another run, I just poured
That's
in the
cool.
adipoyl chloride and then did absolutely nothing. I left it for about an hour and I wanted to see what would happen if I just let it react passively.
Yeah. Oh
When
wow.
I came back, the adipoyl chloride layer was no longer yellow. I poked around with a glass stir rod and tried to pull some nylon using tweezers, but it appeared that everything had reacted. What's interesting is the same amount of nylon has formed here as all of the other runs.
That's cool.
In the other runs, when I pull it out using tweezers, it's
That
an
just looks
extremely
wrong
thin
though,
layer
to be
and it
honest
makes
with
it
you
look
guys.
like I'm pulling out a whole bunch of nylon. However, in reality, there's actually only a very small amount. For the last run, I used a lot more of each, and I thought it would take a while, so I used the drill as well.
Look at that. It just cured a whole cobweb, isn't
Near
he?
the end, it got super messy and was pretty gross looking.
I'd say, look at that. It looks like someone got cocooned up by an alien web. Look at that. That's like something you see on nightmares.
I ended up having to
When
transfer the
Shrek
huge
went
messy
achoo.
blob and restart with a fresh glass rod.
Yeah.
The nylon from all of the runs was combined in the same bowl and given a thorough washing. Mixed with the nylon is a lot of unreacted adipoyl chloride, hexamethylene diamine, and also the fluorescein that I added in. After a thorough washing and having to change the water several times, I'm left with relatively clean looking nylon. I personally didn't do it, but to clean things further, it might be an idea to do a dilute acid and a dilute base
That
wash.
is really
Anyway,
cool
the
looking.
nylon was taken out and squeezed tightly to get rid of as much water as possible.
Wow.
I then spread it out on some paper towel and let it dry for a couple days.
Hey, you know what's better than a $5,000 PC? What? A $5,000 PC that costs $0. It's time to.
Oh, there you have it, guys. We figured out how nylon was made thanks to Mr. Nile Red. I'll see you guys next time. Hit the like and subscribe button when it appears, or just scroll down and hit it if you like this video. I'll be posting more updates later. I apologize I didn't post a Christmas video. I also got a video request from another um, a fan, so I will be making a Gary's Mod short video of the Walking Dead Telltale series. So start looking forward to that. I'm working on it right now, and I will see you guys again another time. Thanks.